Hello everyone, this video is the continuation of Calorimetry Part 3 where we had started solving numericals from Selena Publications Concise Physics Grade 10. For theory part, please visit Calorimetry Part 1 and Part 2 videos. So let's continue with the problem. Now here, an electric heater of power 600 watts raises the temperature of 4 kg of a liquid from 10 to 15 degrees centigrade in 100 seconds. We have to find out the heat capacity as well as specific heat capacity of liquid. So let's see. This is a heater. Suppose this is a heater and its power is mentioned as 600 watts. The liquid which is in this heater, its mass is given as 4 kg. Change in temperature is 15 degree minus 10, which is equal to 5 degrees. Alright, time they have mentioned as 100 seconds. Now in this case, by using principle of calorimetry, heat given by heater, heat energy given by the heater will be equal to heat energy absorbed by the liquid. Alright, which means heat energy given by the heater is equal to power into time, and heat energy absorbed by the liquid will be equal to M into C into delta T. Power which they have given is as 600. Time they have mentioned as 100 seconds. Mass is equal to 4 kg. Specific heat capacity we will be finding out, and change in temperature is equal to 5. So this can be written as 600 into 100 upon 4 into 5 is equal to C. And this will give us as specific heat capacity, which is equal to 3000 joules per kg per Kelvin. They have also asked us to find out the heat capacity. Formula for heat capacity is equal to specific heat capacity into mass, which is equal to, which we have already found out, 3000 multiplied by mass, which is equal to 4, and we get this is equal to 12,000 joules per Kelvin. In this problem, 0.5 kg of lemon squash. That means suppose this is a lemon squash whose mass is 0.5 kg and it is at 30 degree centigrade, is placed in a refrigerator which can remove heat at an average rate of 30 joules per second. How long will it take to cool the lemon squash to 5 degrees centigrade? That means we have to find out the time it will take to cool the lemon squash from 30 degree to 5 degrees centigrade. It means that the temperature difference here, it will be 30 degree minus 5 degree, which is equal to 25 degrees centigrade. And specific heat capacity is mentioned here. Alright, now in this case, heat energy given by lemon squash will be equal to heat energy absorbed by refrigerator, which is equal to M into C into delta T, and this is equal to power into time. Mass we know, which is equal to 0.5. Specific heat capacity is already mentioned. Change in temperature is 25. Power is 30 and time we have to calculate. So this calculation can be performed as 0.5 into 4200 into 25 divided by 30 is equal to T. This 0 can be cancelled. 3 ones are and 40. 25 into 0.5 will give us 12.5 into 140. We can say time is equal to 1750 seconds. In this case, a mass of 200 gram of certain metal at 83 degrees centigrade is immersed in 300 gram of water at 30 degrees centigrade. So let's assume, for our understanding purpose, this is a metal whose mass is 200 grams, which is at a temperature of 83 degrees centigrade. Alright, and it is immersed in a water whose mass is given as 300 grams and which is at a temperature of 30 degrees centigrade. Alright, now moving to the next part. The final temperature is 33 degrees centigrade. So when this metal is immersed in the water, final temperature reached is equal to 53 degrees centigrade. Alright, that means temperature difference for this will be equal to 83 minus 33 degrees centigrade, and temperature difference for this it will be equal to 33 minus 30, which is equal to 3 degrees centigrade, and here it is 50 degrees centigrade. So as of now, what we have understood, a piece of metal whose mass is given, whose temperature is given, when it is immersed in the water of this mass and this temperature, the final temperature achieved is 33 degrees centigrade. So the change in temperature for metal it will be 50 degree, and change in temperature for water it will be 3 degrees centigrade. Now next part is calculate the specific heat capacity of the metal. That means we have to find out specific heat of this part, where we have assuming that the specific heat capacity of water, that is equal to 4.2 joules per gram per Kelvin. Alright, so again applying the principle of calorimetry, heat lost will be equal to heat gain applying formula M into C into delta T. This is for metal and this is for water. Alright, so in this case mass is 200. I am substituting the value 200. Specific heat capacity for metal we have to find out. Change in temperature it is 50 degree. Mass for water is 300. Specific heat capacity they have already mentioned, that is 4.2. Change in temperature is 3 degrees centigrade. Now solving this, I can say 300 multiplied by 4.2 multiplied by 3 divided by 200 into 50. 0 can be cancelled. So I can say here as the specific heat capacity of metal is equal to 3 into 4.2 into 3 divided by 100, which is equal to I can say 3 into 42 into 3 upon 1000, which is equal to 378 upon 1000, which can be written as 0.378 joules per gram per Kelvin. This is the answer. Moving to the next problem. Here, 45 gram of water at 50 degrees centigrade in a beaker is cooled when 50 gram of copper at 18 degrees centigrade is added. So, let's assume this is a piece of copper whose mass is 50 grams. Temperature is 18 degrees centigrade, and when this is added to water whose mass is 45 grams and temperature is 50 degrees centigrade. So when these are added, the content are stirred till a final constant temperature is reached. Calculate the final. So let's assume that when piece of copper is added to water, final temperature achieved is T degrees centigrade. Now they have also mentioned the specific capacity of copper as 0.039. Now temperature difference for copper will be equal to T minus 18, and temperature difference for water it will be 50 minus T. I have seen generally students make mistake here while writing down the difference. Why we have written here T minus 18? Because here copper will be gaining the heat energy. So the final temperature will be obviously higher than 18 degrees, and here water is losing the heat energy. That means final temperature will be obviously less than 50 degrees centigrade. That is the reason while writing down temperature difference here it is 50 minus T, and here it is T minus 18 degrees centigrade. You again using the principle of calorimetry, that is heat gain is heat energy gain equal to heat lost m into c into delta T. Here again m into c into delta T. Substituting the values, mass for copper is 50. Specific capacity is mentioned as 0.39, and temperature difference as we spoke that is equal to T minus 18. For water, mass is 45. Specific capacity is 4.2 and 50 minus 50 into 0.39 is 9.5 into T minus 18 is equal to 189 into 50 minus 3. Performing further calculation, 19.5 T minus 351 is equal to 9450 minus 189T. 19.5T plus 189, and here it is 9450 plus 351, which will give us 0.5T, and here it is 9801. Dividing this 9801 and 208.5, we get as degree centigrade. Moving to the next, 200 gram of hot water at 80 degrees centigrade is added to 300 gram of cold water. So, to start with, this is hot water and this is added to cold water. and neglecting the heat taken by the container, we have to calculate the final temperature. So let's assume that final temperature on mixing these two hot and cold water, final temperature achieved is 3 degrees centigrade. Alright, now mass of hot water is given as 200 grams. Specific heat capacity of water is mentioned in kgs. So we'll have to convert this into kg. Similarly, mass of cold water is mentioned in 300 grams. Converting this into kg, we get this, and the temperature difference for hot water will be equal to 80 minus T degree centigrade, and for cold water it will be T minus 10. Applying the principle of calorimetry, again we can say this is m into C into delta T. This is m into C into delta T. Mass for hot water, it is 200 upon 1000 multiplied by specific heat capacity they have mentioned as 4 to 200 for water. Change in temperature is 80 minus T. Here it is 300 upon 1000 into 4200 into T minus 10. Here this and this can be cancelled. 1000 will also get cancelled. So we have 200 into 80 minus T and 300 into T minus 10, which can be written as 80 minus T and 3 into T minus 10, which is equal to 160 minus 2T and 3T minus 30. Transposing 30 here and 2T on right hand side, we get 190 is equal to 5T, which is equal to 38 degrees centigrade. The temperature of 600 gram of cold water rises by 15 degree when 300 gram of hot water is added to it. So, for our assumption purpose, this is cold water and this is hot water. These two are added together, right? So, mass of cold water is as 600 gram. Temperature difference for this is given as 15 degrees centigrade. It's mentioned it rises by 15 degrees. So, temperature difference for cold water will be 15 degrees centigrade. For hot water, mass is 300 grams, and here we are assuming that final temperature achieved is 3 degree. So the temperature difference for this is 50 minus 3. Here the rise in temperature is already mentioned specifically as 15 degrees centigrade. So we have taken temperature difference as 15 degree here, and here it is 50 minus 3. Alright, now again using the principle of calorimetry, this is m into C into delta T. Mass in this case is 600. Specific heat capacity is not mentioned. Obviously, it is considered as same here. This will get cancelled. Rise a change in temperature for this, it is 15 degree. Here mass is 300. Change in temperature is 50 minus 3. This can be calculated as equal to 50 minus T, which is equal to 30, and 50 minus T. Transposing 3 here and 50 on right hand side, we get, we get as equal to 20 degree centigrade. Now, since we know that change in temperature is equal to final temperature minus initial temperature. Change in temperature, as they have mentioned, as 15 degree centigrade. Final temperature which we have calculated is 20 degree, and we are interested in finding out initial temperature. Hence, initial temperature will be equal to 20 minus 15, which is equal to 5 degree centigrade. T. Temperature of temperature of 600 of cold water rises by 15 degree centigrade. So we have written for cold water mass as 600 grams, and rise in temperature, that is change, is 15 degree. However, for hot water, information given is mass is 300 grams and it is at 50 degrees centigrade. So, rise in temperature for hot water would be this 50 minus final, that is degree centigrade. Substituting the values, we have calculated here T is nothing but a final temperature. However, in the statement they have asked to find out initial temperature, and we have calculated final temperature. That is the reason here we are writing change in temperature is equal to final minus initial. Change in temperature, which is already mentioned, which is equal to 15 degrees centigrade. This is final. Subtracting these two, we get initial temperature. 1 kg of water is contained in a kettle of 1.25 kilowatt. So let's assume this is a kettle and its capacity is, power they have given as 1.25 kilowatts, and the liquid which is inside this is having a mass of 1 kg. Temperature difference, they have asked us to calculate the time taken by the temperature of water to rise from 25 degrees centigrade to 100 degrees centigrade. In this case, temperature difference will be equal to 100 minus 25, which is equal to 75 degrees centigrade. Specific heat capacity is already mentioned here as 4.2, and we have to calculate time required. Alright. Specific heat capacity is mentioned in grams and mass in here 1 kg. So while solving, we need to convert it into grams. By using principle of calorimetry, heat energy given by kettle will be equal to heat energy absorbed by liquid So heat energy of kettle will be equal to power into time, and this is equal to M into C into delta T. Power they have mentioned as 1.25 kilowatts. So let's convert this into watts. That is 1.25 into 1000, which is equal to 1250 watts. So this is 1250 multiplied by time. Mass is 1 kg, which is equal to 1000 grams. C they have mentioned as 4.2. And temperature difference we have found, which is equal to 75 degrees centigrade. On calculating this, we get this 0 can be cancelled. 4 is a 5 is a, which is equal to 15. So I can say it is 4 into 4.2 into 15, which is equal to 252 seconds. Then this was the last problem from the exercise. Hoping that this video will help you. Thank you.